We will see chemical reactions which we come across in daily life. Milk become a curd when it is kept for a long time. It is a chemical process. When nail is exposed to humid atmosphere, it become a rusted nail. This is also a chemical process. When grape when grape is kept for a long time, it get fermented. This is a chemical process. When any food is cooked, it becomes soft so that we can consume it. When the raw rice is cooked, it becomes soft so that we can consume it. Again, it is a chemical process. Now, digestion process is also a chemical reaction. Food which we consume is converted into soluble form which body can absorb. This is also chemical reaction. Means food is converted into energy. Respiration system. Body intake air from atmosphere, absorb oxygen and emit balance air from respiration system. This process is also a chemical process, chemical reaction. We will see magnesium react with oxygen in air and form a magnesium oxide. This is activity 1.1. Refer this figure 1.1, wherein there is a magnesium ribbon. Magnesium ribbon is held in a tongue, and this is a burner by which we are heating this magnesium ribbon. This is the watch glass, and whatever is the product, final product that we can observe on this watch glass. So this is a basic process. We will see activity 1.2. How hydrogen gas is formed after reaction of lead nitrate and potassium iodide. See, this is a flask, conical flask. In flask, we are having zinc granules, and these zinc granules are put in the dilute sulfuric acid. At the top of this is a cork, and in this cork, a glass tube is fitted. So whatever are the gases generated, these gases will exit from this glass tube. So after adding this dilute sulfuric acid in the zinc granule, if we shake conical flask, then reaction will take place. H2 gas will get generated and it will emit from this glass tube. This is also a chemical process. Now let us say activity 1.3. We'll take one flask, we'll add a zinc granule in that, and then we'll add either dilute sulfuric acid or hydraulic acid. Uh, After the process, we can notice there is a change in temperature. This change in temperature we can sense by touching our finger to flask. And during the process, heat is generated. Uh, Now, whenever a chemical reaction take place, we observe some changes. In some cases, change in stage, that is solid form become a liquid or liquid form become a gas. The very first example we have seen how the liquid milk become a solid curd. Then second one is change in color. After rusting of nail, red particle gather on nail. So this is one of the sign during the process. Third one is evaluation of gas. See in our activity figure 1.2, hydrogen gas is generated in beaker which come out of tube. So this is also one of the indication evolution of gas. Then last one, change in temperature. In activity 1.3, heat is generated in a flask which can be sensed with hand. So this is one of the sign of chemical reaction. Now we will see how chemical equation are presented in equation form. Now let us say activity 1.1. Uh, Magnesium and oxygen has reacted to form magnesium oxide. This oxygen is from air and magnesium ribbon we have burned. So the equation we can write like magnesium plus oxygen arrow means it reacts to form a magnesium oxide. Now left side of equation is known as a reactant because magnesium and oxygen are reacting with each other. And right side is a product side, that is magnesium oxide is formed. One more way to express chemical reaction is to write the chemical equation. Uh, it is more precise way to express reaction as it gives a more information about the chemical reaction. So that is the best way to express chemical reaction. So now we'll write above equation in following way. We know magnesium is Mg, O2 is oxygen, MgO is magnesium oxide. So when Mg is reacting with O2, it becomes MgO. So here Mg and O2 on the left side are reactant and MgO is a final product. Now next point 1.1.2, balance chemical equation. The number of atom before reaction and after reaction remains same. So it is necessary to balance equation. We'll see what exactly it means. Let us see equation 1.3. If we express it in the word, it will be zinc plus sulfuric acid interact it with each other to form zinc sulfate and hydrogen. Now if we write a chemical equation for this, it will be zinc, Zn for zinc, H2SO4 that is for sulfuric acid, arrow they are interacting with each other to form a zinc sulfate that is ZnSO4 plus hydrogen that is H2. Now this equation I have marked with two different colors. Left side is a red color and right side is a gray color. Now we will see number of atom at the left side and right side. Now let us see red color that is left side. Left side we have zinc that is number of atom is 1. H hydrogen that is 2. S sulfur that is 1 and O oxygen for 4 O4 means 4 atom of oxygen. Now let us see at the right side. Right side we are having Zn 1 atom. Okay, gray color. Observe this carefully. Then H that is hydrogen. We are having a 2 H2 that means 2 atom of hydrogen we are having. Then third one is S that is sulfur that also one we are having and oxygen O4 that means 4 atom of oxygen we have on the right side. Now if you observe carefully left hand side and right side, that is red color and gray color, you can observe that number of atom at the left hand side that is reactant is equal to number of atom at the right hand side that is a product. So this equation is already balanced. Let us see balancing of equation further. We'll see this chemical reaction Fe plus H2O is equal to Fe3O4 plus H2. Okay. Now there are left side element and right side element as I told you earlier. Now left side I highlighted O with red color and right side oxygen I highlighted with the green color. Now let us see what is the difference first. Let us see the element at the left hand side. Fe we have one atom, H we are having two atom, oxygen O we are having one atom. Now let us see right hand side. Fe we have three atom, H we are having two atom, and O oxygen we are having four atom. Now here we can observe that left hand side we are having only one oxygen, and at the right hand side we are having four atom of oxygen. So this needs balancing. Now basic rule we have to understand is we have to start with maximum number of atom. Now here in this case we are having O4, so we will have to start balancing with oxygen. Okay. Now let us see how we can balance. Procedure to balance the equation. Now we have seen oxygen is maximum having number of atom. So left hand side we are having only one atom of oxygen and right side we are having four atom. So naturally we have to multiply by 4 on the left hand side so that the left hand side oxygen and right hand side oxygen can get balance. So if we do this, how the equation will be Fe plus 4H2O we have multiplied by 4 to H2O complete bracket so that oxygen will get balance. The product will be Fe3O4 plus H2. Now if we carefully observe red color oxygen there are 4 atom, 4 multiplied by O, that is 4 atom of oxygen, and at the right hand side green color oxygen is again O4. So as far as oxygen is concerned this equation is balanced. Okay, now we will see further how remaining part is to be balanced. Now let us see balancing further. We have already balanced oxygen. Now let us see Fe plus 4H2O is equal to Fe3O4 plus H2. Okay. Now here let us see how much hydrogen we are having. At the left hand side it is with red color. So 4 multiplied by H2, that is 4 multiplied by 2. That means we have 8 atom of hydrogen at the left side. And at the right hand side I highlighted with the green color, we have only 2 atom of hydrogen. Okay. So what we will have to do, at the left hand side we have 8 and at the right hand side we have 2. So naturally we have to multiply right hand side by 4 so that equation get balance. Okay. So here in red color we are multiplying by 4. So once we multiply by 4 H2, hydrogen become 8. Okay. And right hand side we are having 2 atom of hydrogen. So what we are doing, multiplying right hand side by 4 so that right hand side H2 become 8 and right hand side H2 match with H2 of left hand side. Have you understood? We have to just make this atom equal. Left hand side atom has to be equal to right side atom. So whatever arithmetic is required that we have to do. So now equation becomes Fe plus 4H2O is equal to Fe3O4. This is at ease, we have not done anything. Plus 4H2, we are multiplying by 4 to balance the equation. Okay. Now equation is balanced as far as H2 is concerned. Now we have balance, first we have balance oxygen, then we have balance hydrogen. Now what is remaining? Remaining is Fe. Fe, let us see, at the left hand side we have one Fe. See, this is one Fe. Left hand side Fe plus 4H2O. That means left side we are having one Fe, and right hand side we are having Fe3. That is 3 atom of Fe we are having at the right hand side. So again this has to be balanced. Now let us see balancing further Fe. Now we have equation Fe plus 4H2O is equal to Fe3O4 plus 4H2. Now again I have highlighted left side with red color and right hand side with green color so that we can see the difference. Now at the left side we are having only one Fe, and right hand side we are having 3 Fe. So naturally what we have to do to balance this equation, we have to multiply left hand side by 3 so that equation will get balanced. So if we multiply by 3, equation will be 3Fe plus 4H2O is equal to Fe3O4 plus 4H2. Okay. Now let us see what we have. Again I have differentiated red color and green color. Left side we are having Fe3, that is 3Fe. Then we have H 8 atom, that is 4 into H2, that is 8 atom of hydrogen, and O, how much oxygen we have? 4 number of atom of oxygen. See this bracket multiplied by 4, so we are having 4O. Now let us see right hand side green color. Again we are having Fe3, 3 number of Fe. Then H, 8 number of hydrogen. How it is 8? Outside bracket we are having 4. Then inside bracket 2. 4 multiplied by 2. That is 8. Then oxygen 4. O4. So now let us see right hand side and left hand side. Both atoms are equal. So now equation is balanced. So this is the right balanced chemical equation. Okay. Now we have seen how to balance equation. Now further we can also indicate the physical state of each reactant and product along with the chemical formula. Gaseous state is represented by small g, G for gas. Liquid state is represented by small l, L for liquid. Aqueous state is represented by small aq, aq means aqua. Solid state is represented by small s. Okay. Now let us see equation 3Fe into bracket s. S is solid. That means Fe is in the solid form. Then H2O G is written. G means gas. Now somebody will ask how water can be in gas form. So water can be in two form. It can be a liquid, also it can be a form of a steam. So when H2O is in a steam form, it is to be indicated gas. Okay. Then Fe3O4, again it is a solid state, and H2 for H2 again hydrogen is a gas. Like this we can also indicate conditions such as the temperature, pressure, catalyst, etc. When we write equation. Now for example, if we write these conditions are indicated generally above arrow line or below arrow line. Now let us see this equation. In this equation it is indicated 340 atm, that we are indicated in red color to understand in a better way. 340 ATM means atmospheric pressure. Okay, this is the condition at which these reactions are taking place. So this is the additional data we are putting above arrow. So this is data, additional data we can put. So equation becomes CO in the form gas form plus 2H2 again in the gas form. It is reacting to form CH3OH that is in liquid form. Now let us see other reaction. 6CO2 aqueous form plus 12H2O. This H2O is in liquid form, not is in gas form. If it interacts, it it becomes C6H12O6. This is again in aqueous form plus 6O2. Again it is aqueous form plus 6H2O. This is in liquid form. Now this reaction take place in the sunlight. Unless and until we have sunlight, reaction is not taking place. So we are indicating above arrow a sunlight. So it is indication that sunlight is required for this chemical action. Okay. Let us see further 1.2.1 combination reaction. Activity 1.4. Take a calcium oxide or a quick lime in a beaker. So this is a beaker. In beaker we have taken the calcium oxide. Okay. Slowly add a water in this. Let us add water slowly. If you touch beaker, you can notice a large amount of heat is generated during the process. Calcium oxide reacts vigorously with water to produce slack lime, that is calcium hydroxide. Now let this one can easily notice this process. After addition, due to heat, it almost boils. So much heat is generated in the process. So chemical equation will be CaO, that is quick lime in the solid form, plus H2O, water in liquid form we are adding. When it interact, it becomes CaOH2, that is slack lime in aqueous form, plus lot of heat is generated. Now reaction wherein two or more reactant react to form a single product is called combination reaction. Here in this case, CaO and H2O are reacting to form a single CaOH2. So this is a combination reaction. Okay. Now let us see combination reaction that is used in whitewashing wall. This wall, this picture I have indicated to show the painting of a wall. That is the only intention of showing this picture. Now when calcium hydroxide react slowly with carbon dioxide in the air to form a thin layer of calcium carbonate on the wall. Now let us see exactly what happens. Calcium hydroxide, that is CaOH2, it is in the aqueous form. When it interacts with CO2, this CO2 is from taken from air. So when these two elements interact, it forms a CaCO3. It is a calcium carbonate plus H2O. Now when this calcium carbonate is formed, this is slow process. It can take a 2 or 3 days. So when calcium carbonate is formed, it gives a shining look to wall. So this is the advantage of this reaction. So we can get a shining finish after when this reaction take place. So similar process can be done on marble also. On marble also reaction will be same. We can see some other example of combination process. Burning of coal. When we burn a coal, it is again combination process. Let us see what happens. C, that is carbon in the solid form, react with oxygen to form CO2. It is burning of coal in the plain language. Okay, so here two elements are reacting to form a one product. So this is a combination reaction. Similarly, when hydrogen react with oxygen, hydrogen in gaseous form, when react with oxygen in gaseous form, it form 2H2O, that is water, plain water in the liquid stage. So here also two elements are interacting with each other to form one product. So this is again a combination reaction. So when two or more element or substance combine to form a single product, it is a combination reaction. Okay. Now let us see exothermic reaction. Reaction in which heat is released along with the formation of product are exothermic chemical reaction. Example we have already seen: burning of natural gas. When CH4 interact with oxygen, it forms CO2 plus 2H2O. So during this process, lot of heat is generated. So this is a exothermic chemical reaction. Then next example is respiration. Respiration is also exothermal process. We need energy to stay alive. We get energy from food, whatever we eat. So during digestion, this food is broken into smaller substance like rice, potato, bread contain carbohydrate. These carbohydrates are broken down to form a glucose. This glucose combine with oxygen in the cell of our body and provide energy. So this is the process during which heat is generated. Energy is a heat. So this is an example of again exothermic chemical reaction. Detail of this process we can see further in chapter 6. Now let us see further equation 1.18. When C6H12O6 glucose react with 6CO2, that is carbon dioxide, it gives 6CO2 plus 6H2O plus energy. Lot of energy is generated. So again this is the exothermic reaction. Decomposition of vegetable matter into compost is also example of exothermic reaction. When we decompose vegetable or some other food, it become a compost uh, which is used in the agriculture crops. So that is also a part of exothermic reaction. Identify type of reaction taking place in activity 1.1 where heat is given along with the formation of single product. Let us see 1.2.2 decomposition reaction. Here let us see what is this experiment. There is a test tube. A test tube is held with a tongue. Here is a burner. Okay, and in this boiling tube we have ferrous sulfate crystal. Now when we heat this crystal with a burner, fumes are generated. Ensure that you hold this boiling tube or test tube away from your nose or face so that these fumes, hazardous fumes, are not harmful to your body. Okay, this is one of the caution we have to take during this experiment. So what happens? Fumes are generated, which are having some odor. When we burn the crystal of ferrous sulfate, odor is generated, a gas is generated which gives odor. We'll see further detail. Let us see further activity 1.5. Take 2 gram of ferrous sulfate crystal in dry boiling tube. Notice the color of this ferrous sulfate crystal. Then heat the boiling tube over the flame of the burner or spirit lamp as shown in figure 1.4. Whatever figure earlier we have seen, the same thing, same process we have to carry out. Two things can be noted during the reaction. Green color of the ferrous sulfate color has changed. Smell of characters Smell of characteristic odor of burning sulfur. So if we see the chemical reaction of this process, it is FeSO4 uh, arrow. What arrow means? We are heating FeSO4. After heating, it is breaking into Fe2O3 plus SO2 plus SO3. Okay. In this reaction, single reactant breaks down to give a simpler product is a decomposition reaction. Now here what is happening? One element is breaking into a number of element, either a one or two, either two or three. So it is a decomposition of that element. So it is a decomposition reaction. Ferrous sulfate crystal FeSO4 7H2O lose water when heated and color of crystal changes. It then decomposes to ferric oxide Fe2O3 and sulfur dioxide SO2 and sulfur trioxide SO3. Ferric oxide is in solid form while SO2 and SO3 are in gases. So this is the same above reaction what we have seen. Important thing, we have to understand the concept of decomposition where one element is splitting into number of elements. That is a decomposition. Let us see further. Decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating is an important decomposition reaction used in various industries that we have seen. Calcium dioxide is called lime or quick lime. This whatever we have discussed is seen earlier. It has many uses. One is to manufacture cement. When decomposition reaction is carried out by heating, it is called thermal decomposition. Here what we are doing, we are heating a limestone. It is breaking into CaO plus CO2. Okay. Here it is a burner. This is a test tube. It is having a lead nitrate, and after burning the lead nitrate, nitrogen dioxide is emitted. You can see this fume. These fumes are of nitrogen dioxide. Okay. Now let us see further another example of decomposition that is given in activity 1.6. We'll see what is activity 1.6. Take 2 gram of lead nitrate powder in the boiling tube. Hold the boiling tube with a pair of tongs and heat it over a flame as shown in figure 1.5. You observe, note the change. You can again observe that emission of brown fumes. These fumes can be easily seen. These fumes are of nitrogen dioxide, NO2. Di means 2, NO2. Reaction that takes place is lead nitrate is lead nitrate in the solid form. After heating is breaking up into PbO, that is lead oxide, plus nitrogen dioxide, that is NO2, plus oxygen, that is O2. This lead nitride is in the solid form. Lead oxide is again in the solid form. Nitrogen dioxide, these are the fume, that is in the form of a gas, and oxygen is also emitted in the form of gas. So this is another example of this reaction. Now let us see further activity. Activity 1.7. Take a plastic mug. This is a big plastic mug. Drill 2 holes at its base and fit rubber stopper in this hole. These are the two bottom drill hole, and we have fitted rubber stoppers. like this. Insert a carbon electrode in this rubber stopper. These are the two carbon electrode we have fitted like this. Okay, now connect this electrode with 6-volt battery. So this is a battery. We have connected these 2 point anode and cathode with the battery. We have provided switch to operate this battery. Now fill this mug with water such that electrode are immersed. See this water level, and these are two electrode which are just immersed. Add a few drop of sulfuric acid to the water. Let us add sulfuric acid. Take two test tubes filled with water and invert them over two carbon electrodes. Now these are test tube we have taken. These test tube are filled with water, and these we have fixed it in the reverse way. Okay. Now switch on the current and leave apparatus for the some time. Now switch on the current. This current will pass. Let us see what exactly happens. You will observe formation of bubble at the both electrodes. This bubble displaces water in the test tube. Now let us observe this carefully what exactly happens. This bubble, can you see this bubble, white color bubble? This bubble are forms during the chemical reaction, and this bubble replaces the water, and this water is replaced by this bubble. Have you understood what exactly happens? This bubble are formed and it is a taking place of water at the top. Is the volume of gas collected same in the both test tube? We'll check up. Now we are continuing this experiment. Once the test tube is filled with the respective gas, remove them carefully. Now this test tube we have to remove carefully. Test these gases by bringing burning candle close to mouth of the test tube. See here we are interacting with hydrogen and oxygen, so we have to be careful when we have to while bringing the flame near the test tube. So lot of care has to be taken. So let us see what happens. I already told you which are these gases in the test tube, but we can check with the help of flame which are these gases. Okay. Now let us see this activity 1.8. This is a further simple reaction we will see. Let us take 2 gram of silver chloride in china dish. This is a china dish. We have taken this silver chloride. Okay. What is the color? Observe color carefully. Place china dish in the sunlight as shown in the figure. See, we have to expose this silver chloride to sunlight. Then only reaction can take place. Observe color of silver chloride after some time. See, this is exactly experiment what we are doing. You can see white color of silver chloride turns in sunlight. This is due to decomposition of silver chloride into silver and chlorine by light. So what exactly is happening when we burn this AgCl, that is silver chloride, it is breaking into silver and chloride. Now this AgCl is in a solid form. What we get a product, again Ag is in solid form, and Cl2, that is in the chlorine is in the gas form. So silver we can get after burning of silver chloride. Then somebody will think that this is easiest way of getting silver. Why to work? Let us collect the silver and sell it in the market so that we can get lot of money. But that is not the case. The cost of the silver produced by this procedure will be more than cost whatever is in the market. Okay, so don't even try for that. So have you understood what is the decomposition process? It is a very simple process. Similar simple process we will see. Silver bromide also behave in the same way. When silver bromide is exposed to sunlight, it is breaking into Ag and bromide. Above reaction is also used in black and white photography. Black and white photography is not used nowadays, but you can understand this process and you can understand very well how this process was utilized earlier in photography. Nowadays, nobody does this black and white photography. Okay, so we have seen that reaction require energy either in the form of heat, light, or electricity for breaking down the reaction. We have seen here in this case we have utilized sunlight. Reaction in which energy is absorbed are known as endothermic reaction. It means sunlight or energy we are taking from outside for chemical reaction. That is called as endothermic reaction. Okay. Now let us see one more reaction. This is also a very simple reaction. It is a 1.2.3 displacement reaction. We'll see what exactly is a displacement reaction. See here, if you see this figure 1.8, there is one test tube. In test tube, there are two nails tied up with the thread, and we have copper sulfate solution in this test tube. Okay, and this is a stand. So we will see exactly what is the detail activity. Activity 1.9. Take three iron nails, clean them by rubbing with sand properly, sandpaper. So what we have to do, three nail we have to take, we have to rub it with the sandpaper so that there is no foreign material deposited on the nail and we can observe a reaction very easily. Take two test tube marked with A and B. Each test tube take 10 ml of copper sulfate solution. Okay, this is simple. Take two test tube, mark A and B, and take 10 millimeter solution in each test tube. Okay. Now tie two iron nail with the thread and immerse them carefully in copper sulfate solution in the test tube B for 20 minutes. Keep one iron nail aside for comparison. Now what we are doing, we are immersing these two nail in this solution and one nail we have kept outside for comparison purpose. Okay. After 20 minutes, take out iron nail from copper sulfate solution. Okay. Let us see what are the observation. Compare the intensity of blue color solution of copper sulfate solution in test tube A and B. Also compare color of iron nail dipped in the copper sulfate solution with one kept aside. Now this detail we can see in the further sketch. Okay. Now let us see further. This is figure 1.8b. We have taken this test tube A and B. These are kept for comparison. Then again these are two nails. One nail which we have kept aside for comparison purpose, and this is a nail which we have removed from the test tube. Okay. Now what are the observation? Why does iron nail become brownish in color and blue color of copper sulfate solution fade? Here at the right side we can see this the blue color of this original solution has faded, and at the left side this iron nail has become a brownish in color. So why exactly this has happened? Let us see. Following chemical reaction take place in this activity. Let us see what exactly is happening. Fe in the form of solid plus CuSO4 in the form of aqua, that is copper sulfate solution in the test tube. These interact to form FeSO4 plus Cu. Now here I have used two different color. Green color is for Cu and red color is for Fe. Okay. Now let us see in this reaction iron has displaced or removed another element copper from copper sulfates. This reaction is known as a displacement. Okay, here let us see at the left side there is only one Fe. This one Fe after interaction is getting associated with SO4. So it is becoming a FeSO4. Okay, so this is the kind of displacement. And here CuSO4, you highlighted Cu with green color. Earlier it is associated with SO4. Cu is associated with SO4. Now after reaction, this Cu becomes a separate. So it is Cu is getting displaced. So it is a displacement reaction. Okay. Different color I have marked for different element so that you can easily notice the difference during displacement. Let us see another example of displacement reaction. Here Zn is interacting with CuSO4 to form zinc sulfate and Cu. This is equation 1.25. Now again you carefully observe two color I have utilized, red color for Cu and purple color for Zn. If you observe at the left side this Zn is separate. Now this is associating with ZnSO4. Okay. So it is a displacement action. And in case of CuSO4, this Cu is associated with SO4. This is breaking and Cu is getting a separate. So this Cu in red color I shown. It is a now separate. Earlier it was associated with SO4. So it is a displacement. Another similar example is when Pb that is lead interact with CuCl2, it form lead chloride and copper. Again I have used the two different color Cu and Pb, red and purple color. You can easily notice the displacement what exactly has happened. Cu which was associated with Cl2 has become separate and Pb that is lead which was earlier separate is associated with PbCl2. So this is the displacement process. Now let us see 1.2.4 double displacement reaction. What exactly is double displacement? We will see. These are two test tube. Okay, in one test tube, it is a containing solution of barium chloride. Okay, another test tube is containing solution of sodium sulfate. Now when we mix together, let us see what exactly happens. Formation of barium sulfate and sodium chloride. Let us see how exactly it takes place. Now let us say activity 1.10. Take 3 ml of sodium sulfate solution in the test tube. In another test tube, same amount 3 ml, take barium chloride solution. Now mix this solution. We will see what exactly is happening. You will observe that white substance which is insoluble in water is formed. This insoluble substance is known as a precipitate and this is short form of PPT. In short it is written as a PPT. If further you are studying chemistry for BSc, you will come across this word again and again, precipitate. So you understand the concept. Any reaction that produces precipitate can be called as precipitation reaction. Okay. Now here again I have used a different color. Sodium sulfate Na2SO4 is reacting with barium chloride BaCl2 to form barium sulfate, that is BaSO4 plus sodium chloride NaCl. Okay. Now here again carefully observe. This is Na in red color associated with SO4. Now this Na has, earlier it was associated with SO4. After interaction it has associated with chloride to become sodium chloride. Okay. And see this purple color barium at the left side. Earlier it was associated with Cl2, BaCl2 chloride. and now it has associated, after interaction it has associated with SO4, that is sulfate, to form a barium sulfate. So both barium and sodium has changed its identity. Okay, so this is a double displacement reaction. Displacement has taken at two places, so it is a double displacement. Now let us see what exactly is happening when white precipitate is formed during the reaction. You see this SO4 at the top side, you can see 2 minus, and at barium Ba 2 plus. So what exactly this plus 2 and minus 2 indicate? Figure at the top of the element, it is also known as the superscript. When we are writing at the top, it is known as a superscript that indicate the electron lost or gained. Okay, if electron is gained, it is indicated by positive sign. If electrons are lost, it is indicated by negative sign. The another product formed is sodium chloride, which remains in the solution. So the reaction in which there is exchange of ion between the reactant are called as a double displacement reaction. Okay. Again, this is a simple reaction 1.2.5 oxidation and reduction. It is very simple to understand. Let us see activity 1.11. Here you can see a figure. It is a very simple figure. There is one china dish. Okay. Below that there is one burner. Heat the china dish containing about 1 gram of copper powder. This copper powder is kept inside, and we are burning this copper powder with burner. Now let us see what exactly happens. The surface of the copper powder become coated with black copper oxide. This color become a black. Why it becomes black, we will see. What exactly happens? What chemical reaction takes place, that we will see. When Cu, copper, react with oxygen, this oxygen is actually from air. It is taken from air. So copper and oxygen react when we heat to form CuO. This is 1.28 reaction. Okay, you understood this. This is a simple reaction. Oxygen we have taken from air and copper we have burned. It is forming 2CuO. Now again we can reverse this process. If hydrogen gas is passed over this heated material CO, whatever is the product that is having a black coating, the surface turns again brown, and as reverse reaction take place and copper is obtained. Again, if we want to reverse this reaction, we have to pass hydrogen gas. So this is the CO, product of our earlier reaction. Then we are passing hydrogen on this one, and again when these interact, again we can get original copper, and H2O is also formed. So this is the reverse reaction. Okay. Now let us see what is the definition of this reaction. If substance gains oxygen during reaction, it is called as oxidized. It is very simple to remember. If we gain oxygen, it is oxidized. When substance loses oxygen during the reaction, it is reduced. Means we are reducing the oxygen. Okay. During reaction 1.29, copper oxide is losing oxygen and is being reduced. The hydrogen is gaining oxygen and is being oxidized. In other words, one reactant is getting oxidized while other is getting reduced during the reaction. Now we will see exactly what is happening with the different color. Now exactly we will see CuO and H2O has reacted to form Cu plus H2O. Now this Cu I have indicated with red color and hydrogen H2 I indicated with the green color. Now when CuO is losing oxygen, it becomes a Cu. Okay, this is the red color element. Here oxygen we are losing to form the Cu. So since we are losing oxygen, it is a reduction. And in case of green element, H2 is becoming H2O. That means we are gaining oxygen. Since we are gaining oxygen, it is oxidation process. That is in green color. So in the same reaction, oxidation is also taking place and reduction is also taking place. Easy to remember. One is gaining oxygen, other is losing oxygen. That's all. Now let us see further simple reaction. Some other example of redox reaction. We'll see what exactly is this. Now here ZNO is interacting with C to form Zn plus CO. Now here also I use a two different color. One is for oxidation, one is for reduction. Here carbon is becoming CO. That means carbon is gaining oxygen. Since oxygen is gained, it is oxidized. And ZNO is losing oxygen to form a Zn. So since it is reducing reduced, since oxygen is reduced, it is a reduction process. Again see MnO2 plus 4HCl interacts to form MnCl2 plus 2H2O plus Cl2. Now here also I use two different color. One is red and one is green. So HCl is becoming H2O, means here it is leaving Cl and gaining oxygen. Since it is gaining oxygen, it is oxidized. Okay, whereas MnO2 green color, it is losing oxygen. It is forming MnCl2. That is, it is losing oxygen and it is combined with Cl2. Since it is losing oxygen, it is getting reduced. So in the same reaction, oxidation is also taking place and reduction is also taking place. So in other words, if substance gain oxygen or lose hydrogen during the reaction, it is oxidized. When substance loses oxygen or gain hydrogen during reaction, it is said to be reduced. Okay, easy to remember. I don't think any difficulty is here. Let us see. Uh, Again 1.3. Have you observed effect of oxidation reaction in everyday life? You must have noticed. 1.3.1 corrosion. Corrosion we have already discussed on the very first page. You must have observed that iron particles are shiny when new. You know very well this. I need not explain again. But get coated with reddish brown powder when left for some time. So when we keep iron pan or nail as it is for some time, and when it interacts with air, it is getting rusty. Some other metal also get tarnished in this fashion. Have you noticed the color of the coating form on the silver or the copper? That we will see. When metal is attacked by substance around it, such as the moisture, acid, it is said to corrode, and this process is called corrosion. Okay, in simple way, it is a deteriorating the quality of the metal. Okay, now here in below figure I have shown you the corrosion of copper, how copper is getting corroded when it comes across with the moisture. Black coating on silver and green coating on the copper. This is the copper I have indicated in this figure. Are another example of corrosion. Corrosion causes damage to the car bodies, bridges, iron rail, ships, and to all objects made from metal, especially those of iron. Corrosion of iron is a serious problem. Every year, an enormous amount is spent to replace damaged iron. You will learn lot more in further chapter 3. See here, rusting, you know what exactly is a rusting or corrosion. To avoid this process cannot be completely avoided, but we can slow the speed of this reaction. We can apply different coating, we can apply different color, or we can do some other processing so that the corrosion become very slow process. Okay. Now let us see example of oxidation in the practical life. This is very important example which we see in day-to-day life. 1.3.2 Rancidity. Have you ever tasted or smelt the fat or oil containing food material left for a long time? See, if you try to eat or smell the food either 1 day or 2 day or 3 day old, you will smell you will smell it badly, and taste of that food will also be different. It will not be a good. So, what exactly is happening when the fat or oil are oxidized? They become rancid, and their smell and taste change. It start giving a bad taste and smell. Usually, substances which prevent oxidation are antioxidant. These are added in the food containing fats and oil. So if we are able to add antioxidant along with this food, it will reduce the speed of oxidation. Keeping food in the airtight container help to slow down oxidation. Now have you noticed when shopkeeper packs some food, suppose you have brought a dhokla, or suppose if you have brought some sweet, before packing, that shopkeeper or that whoever delivers you the packet, he ensured that air is removed from that packet. You carefully observe it if you don't have, if you are not observed so far. Why he is doing so? Why while packing a dhokla or packing some sweet, he is removing the air because that air contains oxygen, and this oxygen is a cause for oxidation. Okay, so if we are able to remove some part of the oxygen, that is air, we are reducing the oxidation. We are reducing the process of oxidation. Have you understood why that shopkeeper or that person who is delivering the material ensure that the air is removed from the packet? This is the real reason. So we are delaying the oxidation process by removing the air from the bag. Another way is, do you know that chip manufacturers usually flush a bag of chip with a gas such as nitrogen to prevent the chips from getting oxidized? Now, this nitrogen is again antioxidant. If we add nitrogen in the packet of this wafer, what will happen? This nitrogen will try to prevent oxidation process because it is antioxidant. So since it will try to prevent oxidation process, the life of food will be more. Okay. So what exactly is done in case of wafers? We are flushing nitrogen. When we pack wafers, we are flushing nitrogen so that life of the wafers in the packet will be more. This is the scientific reason why we are doing so.